Z naught is equal to, so generally this is R plus J omega L by G plus J omega C. We know it very well. For a distortionless line, what is the condition? LG is equal to RC. Here, what I am doing is, for simplification, that is equal to square root of, take R common in the numerator, so 1 plus J omega L by R. Similarly, take G common here. If you take G common here, G into 1 plus J omega C by G. Now, if you observe the numerator and denominator, J omega L by R. So, L by R is equal to nothing but what? L by R is nothing but C by G. So, denominator. So, what happens is numerator part and denominator part cancels out. Because if you substitute for a distortion line, L by R is equal to C by G. Therefore, what happens? Therefore, characteristic impedance is equal to square root of R by G. That is also equal to R by G is nothing but square root of L by C. Okay. So, that is pure real part. So, what is the unit? Unit is ohms only. That is, the unit of root L by C is equal to the unit of R by G for a distortionless line. That is ohms. Therefore, we can call it as also R naught, because since it is a purely real, so we can indicate with R naught also. R naught is equal to square root of R by G, that is equal to square root of L by C. Okay, so this is the characteristic impedance for a distortionless line. Generally, practically speaking, power lines, that is the lines used for carrying AC frequencies, what we are using, that is 250 volts 50 Hz power lines. Power lines need to be lossless. Okay, telephone lines, if you consider telephone lines, for telephone lines, they must be distortionless lines. So, we have to consider these two things into account. Suppose we are going for a power lines. So, your main criteria is the power losses. So, you have to design such that there must be low loss. So, the lines must be like a lossless line. Suppose if you are going for telephone lines, the main criteria is voice. So, the voice must be distortionless. So, the primary thing you have to go for is the lines must be a distortionless line. So, this is practically. So, we discussed general transmission lines, lossless transmission lines, as well as distortionless transmission lines. So, you summarize all the result like this. So, it is case propagation constant gamma is equal to alpha plus j beta. Propagation constant is equal to alpha plus j beta and characteristic impedance Z naught. So, general, that is a general transmission line. What is the propagation constant? Square root of R plus J omega L into G plus J omega C. Whereas Z naught is square root of R plus J omega L by G plus J omega C. For lossless lines, lossless what happens? For a lossless line, alpha is equal to 0, beta is equal to omega root LC. Therefore, propagation is 0 plus, propagation constant is 0 plus omega root LC. Whereas, what is the Z naught? Z naught is equal to square root of L by C, purely real one. Similarly, for distortionless line. For a distortionless line, what is alpha? Alpha is equal to square root of Rg. Beta is equal to similar to lossless line only, omega root Lc. Therefore, what is propagation constant? Propagation constant is square root of Rg plus omega root LC. Here what is characteristic impedance? Characteristic impedance also similar to L by C, or you can replace it with the square root of R by G, because for a distortionless line what is the condition? LG is equal to RC. So that thing you have to keep in mind. So this is the summary of the discussion. So these relations you have to keep in mind. Generally we will get problems based on these relations. One more important point we have to discuss is a lossless line. So a lossless line is, what is the condition? A lossless line means R is equal to G is equal to 0 for a lossless line. Lossless means R is equal to G is equal to 0. Then we can say that a lossless line is also a distortionless line. A lossless line is also a distortion. A lossless line is also a distortionless line. Because for a distortionless line, if you observe, what is the alpha value? Square root of RG. For lossless line, R is equal to 0, G is equal to 0. Then what happens to alpha? Alpha is equal to 0. So we can say that a lossless line is also a distortionless line. But a distortionless line is not a lossless line. But a distortionless line is not a lossless line. Why? Because a distortionless line, for a distortionless line, what is the alpha value? Square root of Rg. But for a lossless line, alpha is equal to 0. But for distortion line, alpha is there. So we cannot say a distortionless line is a lossless line. Whereas a lossless line is a distortionless line. Okay. So this is one of the things you have to keep in mind. One of the important statement. So generally, practically speaking, lossless lines, that is power lines, are lossless lines, and telephone lines are distortionless line in practice. Now we will work out some problems. First problem is an airline. Airline is also called as a lossless line. Airline is also called as a lossless line. So an airline has characteristic impedance Z0 is equal to 70 ohms. And phase constant of 3 radian per meter at 100 megahertz. Then calculate inductance per meter. Calculate inductance per meter and capacitance per meter of the line. This is a problem given. One thing you have to always keep in mind when you are solving problems is read the problem carefully and point out what is the given information and what we have to calculate. Then how to relate the given things in terms of unknown things. So like this, you analyze the problem first of all. so that you will get some good ideas to solve the problem. The solution to this problem is, what is a given thing? First of all, given data, characteristic impedance Z0 is equal to 70 ohms. Phase constant means beta is equal to 3 radian per meter. Frequency, at a particular frequency they given, frequency is equal to 100 megahertz, and yeah, these are given things. And what to calculate? We have to calculate L value and C value. Then how we can relate L and C in terms of the given things? Here one thing important is an airline. Airline is also called as lossless line. We know that for a lossless line, we know that R is equal to G is equal to 0. And one more thing we know, alpha is equal to 0. And we know beta is equal to omega into root LC. Okay. And characteristic impedance also we know, Z0 is equal to square root of L by C. So these are the parameters for a lossless line. Now, what is given things? Beta is given, and characteristic impedance also given. Therefore, how we can relate is, calculate Z0 by beta. Calculate Z0 by beta. Suppose if you calculate Z0 by beta, then what you are getting? What is Z0? Z0 is square root of L by C. By beta is omega into square root of LC. So this is equal to, what happens? Square root L cancels out. The remaining thing is 1 by root C by omega into root C. So this is nothing but 1 by omega C. Root C into root C is equal to C. So Z0 by beta is equal to 1 by omega C. Therefore, Z0 by beta is actually what? Z0 by beta is equal to 70 by 3. 70 by 3. Omega is equal to 2 pi F. Therefore, I want to know capacitance value, C value. Therefore, C is equal to omega into Z0 by beta. That is equal to, so 1 minute, sorry. C is equal to, yeah, this is 1 by C is equal to, 1 by C is equal to, therefore C is equal to 1 by omega into Z0 beta. Therefore that is equal to beta by 2 pi F Z0 C value. Therefore C is equal to, beta is equal to how much? 3 by 2 pi into F, 100 megahertz, 100 into 10 power 6 Z0 value. Z0 value is 70. So if you calculate this thing, how much you will get? You will get approximately 68.2 picofarad per meter. Remember the unit is picofarad per meter, because we have to mention in terms of per length capacitance value. Now we have to calculate L value, because C value already we got. That is Z0 is equal to square root of L by C. So Z0 square is equal to L by C, implies L is equal to Z0 square into C value. So Z0 we know, C we know. We substitute those two values, that is 70 whole square into 68.2 into 10 power minus 12 because of pico. So calculate this value, you will get approximately 334.2 nano Henry per meter. So this is L value. Therefore, L is equal to 334.2 nano Henry per meter and C is equal to 68.2 picofarad per meter. So like this you can calculate the values. So the important thing you have to keep in mind is, first of all, read the problem carefully. What is the given data? What is the required data? That is what is the output required, or what is the thing we have to calculate. So just relate those two things. How we can relate the unknown things in terms of known things. So if you do like that, you can easily get the problem without any confusion. Now problem number 2. So the problem is a distortionless line. A distortionless line has Z0 is equal to 60 ohm, alpha is equal to 20 millinepor per meter, phase velocity is equal to 0.6 c, where c is speed of light in vacuum, speed of light in vacuum. Find R, L, G, C and lambda at 100 megahertz. So this is a problem. A distortion line has Z0 as 60 ohms, alpha as 20 millinepor per meter, phase velocity is equal to 0.6 c, where c is the speed of light in vacuum. Find R, L, G, C and lambda at 100 megahertz. I will give some hint to solve this problem so that you can proceed. Hint for this is, first of all, the condition. This is a distortionless line. So distortionless line means write down all the conditions. Distortion means Lg is equal to Rc. Z0 is equal to square root of L by C, or that is equal to square root of R by G also. Alpha is equal to square root of R into G. Beta is equal to omega into root LC. Beta is equal to omega into root LC. Phase velocity is equal to omega by beta. Beta is equal to 2 pi by lambda also. This also you can relate like this. And one more thing, C value, that is speed of light, 3 into 10 power 8 meter per second. So these are some known parameters for a distortionless line. So just relate these things so that you have to calculate the primary constants, that is R, L, G, C. Now what we can do is, alpha is equal to square root of Rg. Alpha value is given. So this I can write like this. That is equal to square root of R into G value. Where G value I know from this. G is equal to RC by L, because the condition is Lg is equal to RC. So substitute the value here. RC by L. So that is nothing but square root of R square square root of r square c by l, that is nothing but r into square root of c by l, that is equal to r by z naught, because z naught is equal to square root of l by c. Because just why I am going for this alpha is because alpha value is given. So that now I am trying on alpha. Alpha is equal to this value. I want to relate it to z naught because z naught was also given. So r by z naught. Therefore r is equal to alpha into z naught. So that alpha is a known thing, z naught is also a known thing. So that you can easily get r value. Next one is, if you calculate this thing, how much you will get? This is nothing but alpha 20 into 10 power minus 3 into 60. That is nothing but 1.2 ohm per meter. 1.2 ohm per meter. Similarly, go for this phase velocity. Phase velocity is equal to Vp is equal to omega by beta, that is equal to 1 by root LC, because beta is equal to omega into root LC, omega cancel out, so that is equal to remaining thing is square root of LC only. Then this is how I can write is Z naught is equal to square root of L by C. Therefore, Z naught by phase velocity, Z naught by phase velocity, that is square root of root L by C by Z naught is square root of L by C by Vp. So this is nothing but square root of L by C into square root of LC. So CC cancels out. The remaining thing is only L. So Z naught is known thing. Phase velocity is known thing. So therefore L is equal to Z naught 60 by phase velocity 0.6 into 3 into 10 power 8 meter per second. So if you calculate this, you will get 333 nano henry per meter. L is equal to 333 nano henry per meter. Z naught square is equal to L by C, because Z naught is equal to square root of L by C. L is known, Z naught is known. Then C is equal to L by Z naught square. L by Z naught square. If you calculate this, you will get around 91.66 picofarad. And finally the unknown thing is G. So how I can relate G? G is equal to alpha is known, R is known. Alpha is equal to square root of Rg. Therefore alpha square is equal to R into G. Therefore G is equal to alpha square by R. So if you calculate this, you will get around 333 microsiemens per meter. So the unit is Siemens per meter. Okay. Like this you can calculate. What is another unknown thing? Lambda. Lambda is equal to 2 pi by beta. Lambda is equal to 2 pi by beta. Beta is equal to omega into root LC. Therefore omega is a known thing, 2 pi f root LC. L is known, C is known. So that you can easily calculate lambda also. Therefore lambda is equal to 2 pi by beta. or lambda is equal to c by f. C here is phase velocity, that is 0.6 c by f. So this also you can use, this relation also you can use. Okay, like this you can solve the problems. But in our examination we will get multiple choice questions, not like the questions like this. So there may be possibility of asking any one value. Suppose the same problem is given, they may ask for any one value, that is either R, L, G, C. Any value they can ask. So the best thing is solve some the analytical questions also, so that you can get some idea how to solve a problem. We will work out some multiple choice questions later in our discussion. So like this, the only thing keep in mind is read the problem carefully. What is given thing, what is unknown thing, how to relate the unknown thing in terms of known things. That is enough, so that you can easily get the problem.